Hello, in this video I will be covering the parameters used to generate the Elbphilharmonie concert hall using Grasshopper. A brief introduction to the building. The Elbphilharmonie is located in Hamburg, Germany and designed by the architects Herzog and Diemeron. Completed in 2014, it is a multi-use structure primarily functioning as a concert hall composed of 3 halls, an elevated public space, which is this portion over here, and a residential hotel. The section diagram highlights the location of these spaces. So the central space, which acts as the heart of the building, is the concert hall, while the surrounding spaces are considered either secondary or residential. As for the structure, it's composed of 3 major volumes and can be split into a solid volume, a glass facade, and a draped roof. For the first portion of the structure, a rectangle is used to extract a curve using the isotrim battery. The curve can be modified using the MD sliders to follow the plan of the original building. Merging these points, a polyline is used to create the building outline. The boundary surface is then extruded to create the first volume. To create the panels on the base volume, we can use the list item battery to select the front and back faces. And then from there, a quad panel battery is used to split the faces using the slider for the U and V values. A dispatch battery is used to create 2 target lists, and the panels are created by extruding in the Y direction. Another way to generate the same results is using an evaluate surface component and plugging in an MD slider, and this will ensure that the panels will extrude according to the normal. For the second volume, the same polyline is moved up, created into a boundary surface, and scaled using the area as the centroid, and the scale as well as the extrusion can be modified. The railing of the second volume is created using the previous polyline, scaled down once again, and divided into a series of points that can be increased and decreased. A line is then created between these points to create a pipe, which generates the railing, and the radius of these pipes can also be modified. The process is then repeated for the handrail as well. So looking at this image of the roof, we can see that the building's roof ascends upwards to the highest point over here and almost slopes down. So because of this, the curve is then exploded into segments and inputted into the list item battery, in which we are able to retrieve the edge of the highest point and move it upwards. Therefore, we're able to loft between these edges and create a new surface. Once the edges are lofted, a simple mesh is created and the corners of that mesh are anchored. And in order to create that draping effect, additional anchor points need to be introduced. So we get those from the naked birdseed battery, and we plug in both the clothed as well as the naked points, so all the points along the mesh surface, into the curve closest point battery. And from there, we're able to control the placement of these anchor points through the MD sliders. Once the points are placed according to the roof of the structure, the entwine battery goes into the goal objects of the kangaroo bouncy solver, and previewing this on, we get this result. To create the rest of the volume, the anchor points must remain moving in the Z direction. To do this, the mesh is exploded and the boundary surface will be projected onto the XY plane, and lofting between them will give us the solid surface. The second method for the third volume uses the same points from the previous definition as the centroids for these spheres, and these spheres will act as our cutting objects. After adjusting the position as well as the scale of these spheres, a solid difference battery is used to trim the extrusion. Once the solid difference is performed, the VREP is deconstructed and checked for any planar curves. These planar curves are then selected through the cull battery, and then we use the cull battery once again to exclude the base surface. The list item is used once again to isolate the faces. The window panels are referenced as a piece of geometry. A bounding box is constructed, and we select the appropriate plane using the list item battery. The vectors show the projection direction using the midpoint of the geometry. We are able to project the geometry onto the surface using the project point component, and the process is then repeated for each face. Alternatively, the window panels can be created by setting a rectangle as a BREP, and this will act as a singular panel. The 2D points along with the mesh vertices are plugged into the distance battery, which is inputted into the graph mapper, and this will be used to modify the curvature of the window panel. The mesh follows a similar process in which it is put into a bounding box and then morphed onto the surface. Finally, a random reduced battery can be used to modify the distribution of the windows across the surface using the reduction and seat sliders.